meetup group, which is for APEC data community group. They are for the data community and for the biz apps, all the Microsoft communities events you can find out there. And for the YouTube, you can we are all the recordings will be posted on the YouTube channel. So even for data group or BizApp group or Azure community groups, you can find all the recordings there. And if you have any queries, you can email to us. We'll love to hear you. Yeah. And before starts, there are a few reminders. So just keep mute yourself. And if you have any questions, so you can just raise a hand, or either you can put in the chat box. So once the speaker is presenting, after that we'll take all questions. And this session will be recorded. The recordings will be shared on the Microsoft SQL MVP group. And after the sessions, you can put your evaluations, so it helps us to improve the sessions, and your feedback is really important for us. So as I told earlier, our first speaker is Nilesh Gule, and he is Microsoft MVP in Singapore and big data architect. And today he will be discussing about modern data warehouse, big data analytics using Azure Synapse. So if you have any feedback, you can scan the QR code and can provide a feedback. I will maybe hand over to Nilesh.
Yep. Thanks, Asif. Let me start sharing my screen.
Yep.
You see my presentation?
Let me stop. Yeah, mine.
Are you able to see my screen, Asif?
No, not yet, sir.
How about now?
Yeah, we can see now.
Okay. Shall we get started?
Yeah, we can start.
Okay. Hi, everybody. Thanks for joining. Today, I'll be talking about the third part of modern data warehouse using Azure. My name is Nilesh, and if you have not joined the earlier sessions, these are my social media coordinates where I blog and other Twitter handle as well as LinkedIn and my email. Feel free to connect with me. The agenda for this three-part session or the three-part series is to learn about how can we build modern data warehouse using the services provided by Azure. So we started with the first session where we looked at what are the different components of modern data warehouse. We looked at the data lake architecture. We then focused our energy on the data lake storage account, ADLS2, and Azure Data Factory in part 1. And in part 2, we looked at Azure Databricks, which is Spark as a service offering from Databricks. We also looked at Delta tables and some of the performance benefits that we get when we use some of these optimized file formats like ORC and Parquet. And in today's session, we are going to talk about Azure Synapse or SQL Data Warehouse as it was called previously. We already touched base a bit on Azure Key Vault in the previous session, and I'll be again using Azure Key Vault in this session as well. So this is a quick overview of how the main components of modern data warehouse looks like. And this is the part 1 and part 2. So let me recap what we did in part 1. The ADLS or Azure Data Lake Storage Gen 2, it provides us a large petabyte scale storage, unlimited storage capacity. It has the hierarchical namespace, and we also get some of the performance benefits by using a Hadoop compatible driver, which is optimized for the ADLS Gen 2. It's called as the ABFS driver. And in terms of the cloud ETL, we looked at Data Factory. So some of the main features of Data Factory is it offers a scale out serverless data integration and data transformation. So we looked at various options. It has more than 100 connectors, which we can use to connect to cloud data sources, on-premise data sources, traditional RDBMS, as well as the modern data sources, APIs, and almost all kinds of data can be sourced and integrated using the Data Factory. And it also offers monitoring and management capabilities. So we have already looked at all these in the earlier session. In the last one, we covered the Apache Spark or Azure Databricks capabilities of Spark using Azure Databricks service, which is a collaborative Spark-based analytics service. So we looked at the different types of clusters that can be created. We also looked at auto scaling capabilities based on the workload and the fine-grained access controls that are provided as part of the Databricks service. So let's start looking at the last part and the most important one, I would say, about Azure Synapse. What is Synapse? Previously, Synapse was called as the SQL Data Warehouse, and it is defined as limitless analytics service for enterprise data warehousing and big data analytics. So we have so many jargons or keywords here. Let's try to decipher them one by one. So when we talk about big data analytics, the first thing that comes to mind is Hadoop and the main components of Hadoop, which is distributed processing. And when we talk about distributed processing, it's about parallelizing the workloads. And what are the different ways in which we can parallelize? So the most traditional way, or the one which is most commonly used before the advent of Hadoop, was symmetric multiprocessing, or SMP. What happens in this case is you have multiple CPUs which are used to complete the individual processes simultaneously, and they share the same memory disk network, and you basically scale up every time you have the need to increase the firepower of your let's say SQL server or any other server. You add more RAM, you add more processors to that, and these are also mostly based on the SAN. They are hosted on SAN. The alternate approach to this is what is done in things like IBM's Netezza database, which is the parallel processing, massively parallel processing, or what is called as MPP. This uses separate CPUs for running the processes in parallel. So the same program, single program, gets distributed across multiple nodes, and you get shared nothing architecture where each CPU has its own memory, it has its own disk, and you can scale out. If you have to add more firepower, instead of adding more CPU and RAM, you basically add more nodes to your cluster or to your setup. And this is similar concept which is used in Hadoop as well. So when it comes to the SQL data warehouse or Synapse architecture, it follows the similar concept where it uses a control node where the application or the consumer connects to and fires the queries. And then there are compute nodes where the actual work happens, or the work gets distributed, the queries get distributed to these compute nodes. And there is also a service which is used, which is called as the DMS or data movement service. So what Synapse tries to do is, by default, it creates 60 nodes and it shards the data automatically across those 60 nodes. It uses the Azure Data Lake storage as a backing storage, and it tries to separate the compute and the storage part of the whole engine. And in terms of distributing the data, there are three options in which we can distribute the data. First one is hash, where we use a function to distribute the data across the 60 distributions based on a particular column. The other one is round robin, where all the data gets distributed uniformly across all the 60 nodes. And third one is replicate. So if we go to the next slide, we can see that the first one, which is the hash function, it uses one column and a hash function to hash that value. And you can see here that it can have situations where, based on the hash value, you might have different row distributions across different databases. And this is good when you have large joins or you need to do aggregations on large number of tables. This functionality is good. The second one is replicated, where you have very small amount of data in the tables, and if you have to distribute that data or you have to move that data for every query that runs or every processing that happens, it doesn't make sense. So what we try to do is replicate that table across all the distributions, because the volume of data is very small, and that optimizes the query performance. And the third one, which is round robin, it sits in between these two. So that is good for data loading kind of scenarios where you are staging the data and you want to quickly load data into the data warehouse. We can use the third option, round robin option. So before I go into the warehouse unit, let's go into the portal and see how do we provision the SQL data warehouse or the Azure Synapse. So I've logged into the Azure portal and let me go into the resource group. If you remember from the earlier sessions, I have a resource group for Sqlpass, all the objects or all the services that I'm using. So previously I've created the data bricks, I've created the data factory, key vault. I've also created ahead of time instance of Azure Synapse here, but let me just walk you quickly through a process if you were to create a new one. So we can create a new Synapse by searching for Azure Synapse here. There are multiple options which appear when we search for Synapse. The first one is the workspace preview. So what I'm talking now is the SQL data warehouse part, which is migrated or which is renamed as Azure Synapse Analytics. There is also an extension to this, and that is in preview, which is called as the Synapse workspace preview. So maybe once this becomes GA, we can have a session around this. So for this session, I will be mainly focusing on the data warehouse part, which is the SQL data warehouse, the Synapse Analytics part. So when I select this and I click on create, I get the usual options to select what is the subscription I want to choose, what is the resource group, and then we need to create a SQL server, a logical server, where this SQL pool will be hosted. So we can create a pool of resources and we can give a name here like Sqlpass part 3, for example. And I already have the SQL server, so I can reuse that, or I can create a new instance of the SQL server where this pool is linked to. And then we choose the performance level. So this is where we choose what is the level of parallelism we need. And based on that, the initial size of our SQL data warehouse is created. And this is called as data warehouse units or DW unit. And based on the volume or the size of data warehouse unit we choose, we would be charged per hour on that. So the smallest unit here is 100 data warehouse unit, DW100. This is charged about 2 USDs per hour. And as we go up, we would be charged based on the number of the units that we select. So let's say I select the 200 here and I say apply. Then I get the next set of options, which is the networking. Where do I want to position this service? Is it within the private endpoint or within my firewall? Or I want to expose it using the public services. I can add a private endpoint here to access only from the virtual network. Let's say I have a virtual network created, then I can expose that only to this virtual network. So in the interest of time, I would say we skip this part because I've already created this service. So let me go back and we can look at the properties of the one which I've already created. So you can see here that I have the SQL server and the SQL pool created. Let's go into the SQL pool and we can see that it has this Gen 2 DW100 units because I created this with the minimum configuration, and it has the other features like geo replication. It can have a geo backup. Also in terms of the security, we can have advanced data security enabled, where we can look at the classification of the data. If there is any vulnerability in the data, all that can be done using the advanced threat protection facilities provided by Microsoft. We also have auditing in terms of what queries are run against the SQL server. Currently, it's not enabled on this server, but if I enable, I will get the audit log by default. And then we have the connection settings where I can control the firewalls and the virtual connections which are allowed to connect to this particular SQL server. And from a data security point of view, we also have transparent disk encryption. So in the previous session, there was a wonderful talk about data encryption and how we can encrypt data. And the speaker had spoken about the TD, how does transparent disk encryption work. If you're interested, you can go back to that video from the last session and you can have a look at that. So again, in this scenario, I have not enabled the data encryption, but it's just a flag. And once I enable it, it is enabled for my SQL pool. So these are the common properties. We also get the connection strings in order to connect to this particular data warehouse instance. And we get like ADO.NET, we get the JDBC connection, ODBC, PHP, and Go. We can just take this connection string and use it in our application. Now let's go back to the presentation. So how does this data warehouse units impact the execution? If you remember, I created DW100 as the parallelism or the mode of parallel nodes for my data warehouse instance. So that is where the engine, the SQL data warehouse engine, tries to connect to the workers, or it creates those many number of workers to work with those 60 instances of the data that is in my storage layer. So if I select 100, I will get one worker. But let's say I change the number of data warehouse units to 600. In that case, the engine is same, but now it has access to 6 different workers and it can parallelize the work more. And same way, if we increase the number of workers or the data warehouse units, we will have more number of workers. So this data warehouse unit becomes your unit of or degree of parallelism in terms of how many workers are allocated to your engine. Now let's look at how we can use this SQL data warehouse in our solution. So we talked about Spark last time, how Spark can be used to optimize or how Spark can be used to read data. So I'm going to extend that same example, the processing of CSV data or processing of that movie lens data set, and add the flavor of SQL data warehouse into this. So in this notebook, I'm processing the ratings file, CSV file, and I go through reading the CSV file, and then I do a filter here. Initially, I just display all the records and I write it into CSV output. Then somewhere down the line, you would see me filtering this for ratings which are greater than 3. And what I'm trying to do now is I want to write this filtered ratings or the filtered data frame to the SQL data warehouse as my process result. In order to connect to SQL data warehouse from Spark, I need a couple of things. So this diagram talks about what are the ways or what are the different connection points which are required in order to connect the Spark with SQL data warehouse. So from the previous session, we know that Spark has this driver and the executor part, where driver is like the main program which drives the distributed workload, and executors are the ones which actually perform the parallel work. So from that point of view, when we want to connect to the SQL data warehouse, Spark driver uses a JDBC connection, which is the normal username, password, and the SQL server and the database. So if I go back into that connection string, this is what I will be using to connect. Okay. And it uses JDBC connection. So I can take this JDBC connection string and I can put it in my Spark code. Once the Spark driver has the connection, the way these executors work is instead of writing data one by one to the SQL data warehouse, it tries to batch all the data that is processed and write it in one shot. And for that reason, it creates a temporary location in the data lake storage where the executors connects to the data lake storage using storage account key or the OR token. And then they write this data into data lake storage. And from the data lake storage, there is a connection which the SQL data warehouse uses. The storage account, it writes it into the SQL data warehouse like a bulk insert. That is again done using either a storage account or using a managed service ID or MSI. So for this purpose, what I have created is I've used the managed service ID. And the way this works is for my SQL server, I assign an identity, and this identity is given access to the storage account. So that way, when I go into my storage account, if I look at the different access, who has the access, I need to give permission to that SQL Server account or the ID, the managed identity, so that it can work with this particular storage account. So here you can see that it has been given a storage blob data contributor access, and because it has this access now, that can write back into the SQL data warehouse. So that is how we have this connection established between the storage account, the Spark driver, and between the SQL data warehouse and the Spark driver. So let me go back into the notebook. So this is what is happening here. What we do is we use the data frame and we use the write function of that. We use a custom driver or a driver which is provided by Databricks for SQL data warehouse connectivity. So this is like your ADO.NET driver or JDBC driver or SQL driver, which is available for other connectivity options, but this is optimized for SQL data warehouse. And then we provide the connection string. So this connection string is of the format, which is what I showed just now. So it is this JDBC connection, but I am retrieving this from my key vault. So from the security point of view, I don't want to expose the username password, and I'm using the key vault for that. So if I go into the key vault, you can see that I have created a DW JDBC connection string as a secret, and that secret has that value, the whole connection string. So I'm using this, I'm redacting that as part of this connection string fetch here using the DB utils and the secret scope. So in a secure manner, I get the connection information. I don't have to expose anything to the end users. And then I use this MSI. So this is that option which allows me to write data from the storage account in bulk insert mode into the SQL data warehouse. And then I provide the table option. What is the name of the table that I want to store in the SQL data warehouse, and the option to the mode that I want to use. So since this is like the ratings which are greater than 3, I don't really care what were the earlier ratings. What I want to do is just overwrite the complete table here. So I overwrite if there is existing table that will be overwritten using this mode as overwrite. I also have the mode as append if I want to append the data instead of overwriting it. And finally, I specify this option, which is the temp directory, where I want to temporarily store that data. So I'm storing it on my file system. So this file system name is the ML latest, and the directory name is I'm not using the directory name. So I basically use ML latest, then the storage account, and I create a temporary folder where this data would be temporarily written. And once the data is available, once everything, all the processing is done, it will be bulk inserted when I call the save method. So that is how Spark is interacting with the SQL data warehouse. So let's connect to the SQL data warehouse and see if this data is available. In order to connect to the SQL data warehouse, I can use SQL Server Management Studio, SSMS, or I can use the this Solution Explorer, not the Solution Explorer, the Data Explorer, Azure Data Explorer. So this is a cross-platform tool, and I'm using Azure Data Explorer in this case. The connection is same like we do in the SSMS. So I can use the SQL login. I can provide the server name, username, and password here. And once I'm connected, I would be able to see the databases. So we have the system databases, and we have a database named SQLST pool created here. And in the tables, you can see that I have this filtered movie ratings table, which I can query using normal SQL query. So let me just fire this and see the results. So we can see that those filtered ratings, I'm grouping them based on the rating ID or rating, and I'm counting the number of users and counting the number of movies. So this is the number of users and the movies based on each type of the rating. So now we have gone and from our filtered ratings, written them onto the Azure Synapse or SQL data warehouse. Let's look at the other scenario where I want to read that data. So for this purpose, I will use the other notebook which I had in the previous session. So this one is where we filter based on the different types of data, where we try to partition the data based on ORC, Parquet, or Delta files. So I've taken one of that data set or data frame, and I have written it the whole, all those 700 MB or 1 million records. So the concept is same here. When I try to write, it's writing the complete movie ratings table. So all the other things are same here in terms of the format or the driver, which I use, the connection string, the MSI option table, and the temporary directory. Once it is written, I want to read it back. So for reading, I use the spark.read function, and I use the load instead of save, and the table name is movie rating. Once I've read that data, then I can show it, or I can just visualize it. And if you're familiar with the notebook features or Jupyter, we can also visualize the data. So I can, instead of just seeing a tabular data, I can visualize it using pie chart or using bar chart, or all these options which are available. So that is the flow, or that is how we interact from Spark with the SQL data warehouse. The next step I want to do is, once, let's say I'm a data engineer or I'm data scientist and I've built this notebook, how do I integrate this in the end-to-end workflow, where I integrate the data, I process that data, and then I store that data in the SQL data warehouse. So for that purpose, I can use Data Factory, and I can create a pipeline here. If you remember last time, I had shown how to trigger a Spark job from Data Factory. So I will use this same pipeline, and I will call a Databricks notebook from here. So in this Databricks notebook, I'm connecting to the same notebook which I showed just now, the query performance partition, where it will write into the partition table. So it will call this, and it will write the data. So there is nothing special in this. What I want to show is the other part, where if I want to get data from SQL data warehouse into Data Factory. So for that purpose, I need to create a connection or the link service, and I've established a connection here. And let's walk through the properties of that. I'm using the autoresolver runtime to host this service or this link service. I can get the service name from my Azure subscription. So I'm connecting to the SQL pool, and then I can specify which method I want to connect using a service principal, managed identity, or SQL authentication. In this case, I've chosen SQL authentication, and I need to provide the username and the password. So password, again, I'm taking it from the key vault instead of hard coding the password and exposing it to the end users. I'm connecting securely, and the password name or the secret name here is Synapse password. So in this case, I've stored just the password in key vault. And I can test this connection. You can see that the connection is successful. That means using this, now I can connect to SQL data warehouse. I have a pipeline which is pulling data from SQL warehouse. Let's say I have a scenario where data is stored in the SQL warehouse, and I want to give an extract of that, or I want to transfer that data into a different format. So what I did is I created a pipeline here, which would transform that data into a JSON file. And in the source, I created a data set which is looking or connecting to that ratings data source from SQL data warehouse. And in the sink, I'm connecting it to a JSON file. And when I execute this, I've already executed this pipeline. and we can see it here. You can see that it is able to pull all the information about 600 MB, these many number of rows using one connection, and then it writes this data as JSON file about 1.8 GB on the ADLS storage. So this way we can connect the SQL data warehouse using Data Factory. We can process those results and write them back into the data lake storage. Next, I would like to also show about the external data sources. So external data sources, if you come from a Hadoop background, you might have heard about things like the managed tables or the external tables. When we work with Hive, Hive has this concept of the managed and the external tables. External tables, what they allow us to do is to separate the data and the metadata part of it, or the definition of the schema of the data. So even if we delete or drop the external table, only the metadata or schema of that table gets deleted. Data is still residing in the location from where we refer to the external table, or these tables are not part of the SQL warehouse. They are created externally. That's why it's called as external tables. So let me show you how to create the external tables or external data sources. The first thing we do here is we create an external data source. So let me just minimize this. External data source is like a pointer to data which is not sitting inside SQL data warehouse. It's sitting in the storage account, but we want to refer to that data. In this case, I'm creating a type of Hadoop external data source. I want to name it as movie lens external, and the location for that is my ML latest file system and the root level of that. And I'm using a managed service identity to connect to this external data source. Once I have the data source, I can define the file format, and these file formats are the ones which we discussed last time, like the object storage or the row columnar storage, the optimized files for the object type of files. So here I'm connecting to a CSV file, or I'm creating a file format for CSV, and I specify different options. Like I know my first line in my CSV file is a header, and the actual data starts from row number 2. So I'm giving first row as 2 here, and what is the field terminator? In this case, since it's a CSV file, it's a comma as the field terminator. So I can specify these options, and I create external file format here, or external the format with which I want to interact with those external files. And finally, I create an external table. So this is just a metadata or the schema which I create on top of that external file. So based on the number of columns that I have in my CSV file, I define the schema that I need a user ID, a movie ID. These are integers. The rating is float, and there is a timestamp which I'm converting into int here. And this table is named as the movie rating external. And the location for this is the ratings.csv from my movie lens dataset. So we start from the data source, which is the top level file system, and then we refer to the relative folder here within that data source. And I also specify which is the data source. So that is how this link happens between the actual file, the ratings.csv, and the data source. And then we also link it with the type of the file format. Now, what happens in this case is I can query this table without moving the data from the storage account into SQL Data Warehouse or Azure Synapse. This query happens in place, or data is still in my storage account, and I'm able to query that. So let's see here how we can query that data. So I'm firing a normal select query here on top of that CSV data, and I'm just referring to that as a normal table rather than treating it as a CSV. Okay, so you can see that here it's now able to get the data from that CSV file or from the storage account. Now this data is not in the managed table or the internal table. It is as an external table. We can look at this by going into the storage account. So let me switch back to the portal and we go into the storage account. Let's go into the location from where it's pulling that data. This is the ML latest file system and we have the movie lens. This is the file which I'm referring to, ratings.csv. So what I will do quickly is let me drop this table. And let's see what happens. Now, this table has been dropped. You can see here. We don't have that external table. Let's see what happens to the data. You can see that the ratings.csv file is still there. It did not delete the data. That is the benefit of using these external tables. Now, if I create the table again, the schema using external table, we would be able to query it again. So let's refresh here. Now we have the external table created. Let's query this again. And it would take some time, but we should be able to get the results from there. So that's one of the benefit of using these external tables. So in terms of the external data source, what we have support for is the Hadoop as well as data lake storage, ADLS. This is how we create the connection to the external data source. We looked at the external file format for CSV, but there is also support for the Hive row columnar file format, RC. There is ORC file format and Parquet is also supported. There is also support coming for JSON. So all these optimized file formats are currently supported as part of the external file formats. We can also use extended properties like the data compression, even if the file is compressed using gzip or snappy kind of compression technique. We can still work with those files and we can have different date formats and field delimiters, which are commonly used across these file formats. Then we also looked at the external table, how to create and query that. Before we move on to this, let me also show you some of the things which we get as part of the monitoring. So when we provision the service, the data pool or SQL data warehouse, we also get built-in monitoring or metrics. So I can go into the monitoring section and I can monitor the queries which are run. I can also look at, let's start with the query activity first. We ran some queries here and you can see that I get built-in or out of the box the different statistics about the query. I can look at which query ran. So there was a query which was getting all the movie ratings and I can find out how much resources were used for that query, how much time did it take to run that query. All this kind of statistics and the workload type, all this is available. We also have different metrics which we can measure. Like I want to say, see how many data warehouse units are used. I can create a dashboard here quickly to see how many units are being consumed. And I also get this self-service kind of capability where I can select a different time range and I can see this data across different time ranges. Another good feature of this is we can also pause the SQL data warehouse. So you can see here that there is a pause option. Let's say because the compute and the storage are separated in SQL data warehouse, if we don't need the compute capabilities, then we can pause while the processing power is not required, and the data will still be available because the data is stored in the storage account. We can also scale this. So let's say I started with initially 100 or 200 as data warehouse units. I can scale it to a higher value here. And the last part which I want to show is the workload optimization, or we can assign resources, we can limit resources. If you worked in, let's say, Hive kind of scenario, or big data using Yarn resource management on Hadoop, this concept is similar, where we can limit the number of resources which are allocated to the queries or the jobs which are running. So what this does is we create a work group here, and it tries to assign minimum resources, maximum resources, and we can cap it. So this is to avoid, let's say, one process taking whole of your data warehouse resources. If you have the need to have multiple users or multiple systems or multiple processes running concurrently, you can limit the number of resources which are taken by a particular group of resources or particular jobs. And this allows us to set limits, set caps on those resources which are used for one individual group of resources. So that was about the workload management. Now let's look at some of the things where SQL data warehouse might not be a good fit. Because we are talking about big data analytics and the MPP kind of architecture, there are scenarios where although all these good capabilities come in out of the box, this SQL data warehouse or Azure Synapse might not be a good choice. First one is if you have an operational workload or OLTP kind of scenario where you have high frequency reads and writes, and you're doing very singleton kind of queries. This is not the kind of scenario we should be running, or this is not the kind of workload we should be running on SQL data warehouse. Also, if we are having very high volume of single row inserts, like a streaming kind of scenario where we have many small inputs coming in, and these are very unitary in nature, it is not good to be part of SQL data warehouse. Data preparations are another case where it's not good fit, and incompatible file formats like XML. Where it's really good at is in case of analytics. If you are working with large quantities of data and you really need that big data analytics firepower, then this is really a good fit because you have those shards automatically created. There are 60 instances where the processing can be parallelized and large volumes of data can be stored. You can model them, you can shape them, you can transform them using SQL-like queries or using the familiar SQL syntax. And when we are running the analysis across large data sets. So it's really suited for analytics use cases and where the data sets is very large. So in summary, what we looked at is the Azure Synapse. It follows the MPP architecture, massive parallel processing. It can be paused when we are not needing it or when we don't need all the compute power. It can be optimized for analytics workloads using that work group isolation mode. It supports external file formats and it works with Polybase. So Polybase is a technology which is used to work with external tables, and it has been there even with SQL Server since 2016, I guess. It is working hand in hand with the Azure Synapse. And this is used when we use those Spark jobs. So if I go back into Spark and where we were running those Spark queries or Spark operations, I should be able to show you where Polybase is getting used. Let me run one of these. So partition, okay. Let's clear all these results and state and run all of this again. So the polybase gets used in this temp directory location where we are trying to write the data temporarily. When the SQL data warehouse and Spark, they use this temporary location, polybase is used internally by the SQL data warehouse connector. With the recent version of Databricks runtime 7 and above, the process here is actually optimized and it's using copy activity, which is even more optimized than polybase. So if you're using the latest runtime of Databricks, it would use copy instead of polybase for writing. But I saw that when it tries to read, it is using polybase. So when it comes to this cell here, while reading, we should be able to see somewhere here that the polybase is getting used. So you can see here, this is where when it's reading that data from SQL data warehouse and presenting it using these notebook cells, it's trying to use polybase to bring that data into that temporary location. Okay. So these are some of the references I would share with you. These slides will be available on Speaker Deck and SlideShare, so you can go through them. I've given the references to what is different between a SQL Server and SQL Data Warehouse, some of the main differences, and then the links to what I've discussed during this demo from Synapse, the workload management, the external files, the tables, file formats. And there was also this SQL Data Warehouse benchmark, which was done a couple of years back, where Microsoft published with the help of a third party that SQL Data Warehouse is quite performant or one of the best when it comes to dealing with large quantities of data. So maybe we can quickly have a look at that. And if I remember, it was more than 20% faster compared to the other cloud warehouses from the competitors. So you can see the results here using the standard TPCH benchmark. It was much more faster, for the 67% faster than Amazon Redshift when it came to workloads of the size of 30 terabytes. And then if you're interested in exploring more about the SQL Data Warehouse, there is also a MS Learn module or a learning path, which is about 3 hours worth and consists of 3 modules in that. You can have a look at that. Thank you for attending this session. Please provide the feedback. And in case you joined in late, my name is Nilesh, and these are the different options using which you can connect with me. Thank you. If you have any questions, I'm happy to take them.
Hi, everyone. If you have any questions, you can either ping in the chat box or you can directly unmute yourself and can ask.
Yeah, I do have a question, Nilesh. Last week we discussed about Azure Databricks, right? And looking at the demo today, there's a lot of overlap on what you can do on Databricks and on Synapse. Is there a good convention on when to choose Synapse over Databricks, or between Databricks and Synapse? Is there any good advice on when to use what?
That's a very interesting question, Pio, and there is a lot of discussion going on this topic. The general thing is, if you're dealing mainly with structured kind of data, right? If your main thing is to work with structured data and consolidate that using SQL queries, then the Synapse scenario is good. If you don't want to move too much data, you can just land it in data lake storage. You can create external tables, and you can use the combination of these external tables plus the managed tables that you have within Synapse. But let's say you have data which requires much more complex processing. You need those Spark kind of features where you have, let's say, semi-structured data or data which is sitting in images, PDF files, and you need to process that kind of data, then Databricks is a good option. So I would say it depends on the use case. And in fact, with the next version of Azure Synapse, they are coming up with Spark on-demand capabilities as well. So whatever we are doing with Azure Databricks now can be done as part of the Synapse workspace itself. So there is going to be integration, native integration, without using the Databricks, but using Spark as part of Azure Synapse itself. So I think it also depends on the kind of data that you're dealing with. So things like many people now work with this ORC files or Parquet files, Avro files. So Spark has better support for them. It is coming to Synapse, no doubt, but there are a lot of jobs or there are a lot of code which has been written to work with this kind of data. And then it might be easier to work with them using Spark as compared to working with just CSV file or normal tabular data.
Awesome. Yeah. Are there any other questions? Let me just check on the chat. Anyone else?
No, I think there's no other questions.
All right.
Okay, thank you.
Okay, thank you, Nilesh. It's really nice session. Yeah. If anyone have any questions, you may ask, or you can also maybe email or to us to Nilesh, and maybe on Twitter or Facebook. Yeah. Or if please help to provide your feedback, which is already we have pinged the feedback link on the chat box. Okay, so yeah, let me share my screen.
Yeah, thank you very much, Nilesh, for a great three-part series.
Thank you. Yeah. Thanks for hosting me.
Hope it's not the last.
Yeah.
Yeah, so everyone, while ASIC is transitioning, if you can provide your feedback, the evaluation form link is on the chat. So it would really help on improving the sessions, and as well as a good input for the speakers. If you have any questions that you would like to ask, you can also course it through the feedback, and then we'll relay it to Nilesh.
Yeah. So we'll start in a couple of minutes. Our next speaker is Nagendra Singh Vidde. He is from Microsoft, Senior Technical Specialist. So he'll be talking about Oracle to Postgresql, match made in heaven. Yeah, it's a really nice topic. So.
By the way, thank you everyone for joining us every 2 weeks on these data sessions. I can see some of the names are very familiar, so you've been with us for the past few episodes. So thank you very much for joining the sessions. If you have any feedback or any questions, feel free to drop them now while we're waiting for Nagendra to start.
Hey guys, I'm ready actually to start, but let me know. Yep.
There you
go. Then I think yeah, maybe you can start. Let me stop sharing my screen. Yeah.
Okay, I will start by sharing my screen. Guys, can you confirm if you can see my screen now?
Yeah, we can see.
Okay. So today what I will be discussing about is how do you migrate from Oracle to Postgre, and why is it said that it is a match made in heaven, right? So essentially, if you look at a lot of market study, lot of people are actually right now saying that PostgreSQL is a very good match in terms of compatibility with Oracle. So we'll look at some of the stuff there, and also we'll look at what are the tool sets available that can help you migrate that. And then I will also talk about what are the Azure benefits that you can leverage with running PostgreSQL as a managed service on the Azure cloud, right? So a small introduction about me. I'm a technical specialist at Microsoft. From my personal interest perspective, I do a lot of coding in various different languages. So yeah, and I'm kind of confused as to which is my which is my favorite language as such, right? So I started with C Sharp, then went into Python, and then all the other things like T-SQL and PL/SQL and all that. So it's a kind of confusion. I can't say I'm specialist in one of the language for that matter. This is my GitHub link and my LinkedIn link. So in case if you want to connect with me, do send me a request there, and we can connect on various social platforms as well. Okay, so first we'll start with as to what are the triggers for a particular person who's looking to migrate, right? First and foremost, what are those triggers which eventually make people migrate from Oracle in this case, right? So we are discussing about Oracle. So essentially, based on my experience with working with some of the customers where we have migrated them from Oracle, we see that they are looking at multiple dimensions here. One of the dimension being cost, which is comprising of either they are trying to exit the data center. It could be a co-located data center or their own data center where they are paying a huge sum just to maintain that data center. They are trying to exit the data center, and meanwhile, while going to the public cloud, suddenly you have a lot of options that you can migrate to, right? So obviously, cost being one of the biggest factor influencing this kind of migration. Data center license cost, these are one of the top two driving factors of what people, what is driving the people to migrate off Oracle to a more, I would say, manageable platform, right? Other than that, the other factors that we look at or we see with the customers is also the manageability part, right? So let's say in your present data center, if you are running through virtualization, right, and you are already running at the upper bound of your resources limit, you are pretty much limited from the perspective of being able to elastically scale your resources based on the seasonality or workload that you experience, right? Usually we have seen out of the 100 Oracle customers, 80% of them are over provisioned in terms of hardware, in terms of licenses, and the simple reason being they always want to be at the max capacity because data centers usually are not elastic in nature, right? So they always aim for the 90 percentile for that matter in terms of resource consumption, and even if that 90 percentile spike are once in a year or twice in a year, they still have to provision for that kind of hardware or resource limits, right? Other than that, from manageability perspective, the other factors that drive people out of data centers or Oracle to more cloud-based platform is also the hardware updates, the software updates, security, compliance, and also we've seen a lot of customers coming to us and saying that 11G is out of support, 12c would be going out of support in some time. So they are looking at options to migrate to. And other than that, there are security and compliance related issues as well that are influencing them to drive out of the on-prem kind of or legacy kind of environments. Now, what are the different pathways which you can look at if you're trying to migrate out of Oracle, right? So there are primarily three patterns that we have seen with the customers, right? The first one being the most simplest. It's like a lift and shift, right? What you're running on prem or on a co-located data center, you simply move the VMs across to Azure, and you can run with your own Oracle licenses in the Azure cloud. This we have seen a lot of people taking this route where they first migrate from on-prem to Azure cloud running on Azure VM, and after it has stabilized, they look at migrating at other managed databases, right? Now, why they choose to do this is most of the time people think that migrating out of Oracle is a very complex task. Most of the time we have seen customers and they don't even know what kind of features they are using, or either they are bind to this high-tech buzzwords like RAC or Oracle Exadata, and they don't know actually whether they can move out or not, right? Apart from that, we have also seen customers where they have a lot of insights about how they are using Oracle, what are the different tool sets and features they are using. For them, moving to a managed database is much simpler, right? And again, there it's a choice between going to open source like a Postgresql or going to a proprietary code like SQL Server. Again, nothing bad in between the two. What we have seen is PostgreSQL wins in terms of the compatibility, because the PL SQL that you run on Oracle has a close affinity with PL/PG SQL, which is the programming language in PostgreSQL. So based on that, we see a lot of customer momentum towards PostgreSQL, but again, SQL Server is also a good contender here. And there may be scenarios where, let's say, a customer is using a Oracle database on a vendor provided application or commercial off-the-shelf kind of application, which have been certified by the vendor to run on SQL and not on Postgre, right? So those are contenders which go towards SQL for that matter. But as I said, if it's an application where the customer owns the code, we have seen close affinity of moving towards PostgreSQL. And why is that? We will come to that discussion in the next slide, right? So Oracle to Postgre, right? Why is this a more preferred choice? And this is not something which I am saying out of my own gut feel. This is what we have seen with customers migrating off Oracle when they did a assessment with SQL Server versus PostgreSQL. There were few factors which made them lean towards Postgre, right? Obviously, there are things that can be done on SQL which cannot be done on Postgre, vice versa. But there are certain factors which naturally leans toward PostgreSQL. One of them is the extensibility that PostgreSQL offers. So if you are a PostgreSQL user, you would know that you can extend PostgreSQL by a lot of extensions that are available that can be installed on a PostgreSQL database and can use to leverage different capabilities. One of a couple of few favorite extension, or more I would say popular extension, is time series DB, and there are other extensions like H store. So essentially these will bring, or will extend PostgreSQL with lot of different features. For example, HStore, right? This extension will give you data types where you can store key value pairs in your database, much like edge stores that you see in other big data databases, right? Now, imagine this, right? A relational database clubbed with a key value pair typical of a edge store in the same database, right? Living and staying in the same database, you can club those two data types with same T-SQL or PLPG SQL statement. That's I mean, innovation in itself, right? So those kind of feature-rich extensions are what is driving more customers towards PostgreSQL. Apart from that, obviously, as I said, cost is a factor because this is out and out community edition. There is no license. It is much cheaper than the other databases that are available on the as a managed service. Apart from that, customers also are more leaned towards community edition, where they are not having a vendor lock-in. They want to break away from the vendor lock-in, right? So believe me or not, Oracle, SQL Server, these are all proprietary code, which means that once you go into that, it is hard to move out because you would be getting too familiar with their programming structure. Your application would be using inline queries, which would be hard to migrate, right? So this kind of a paradigm shift we are seeing with the customer, where they are saying they want to adopt open source more because they want to break free of a vendor locking, right? Apart from that, as I said, there is a lot of affinity between Oracle programming and PostgreSQL programming. If you have heard of the extension called Aura FCE, now this is an extension which you can install on PostgreSQL. The moment you do that, it will expose a lot of built-in functions of Oracle. Notably, if you know Oracle, the dual function that is available, the dual table which is available in Oracle, once you install Aura FCE, the dual table is available there as well, right? So these kind of extensibility in and compatibility in programming language is also one of the driver where we are seeing people adopting PostgreSQL over Oracle. And apart from that, I will talk more about what Azure has to offer for PostgreSQL, but these are top reasons where we are seeing customer moving towards PostgreSQL from Oracle workload. Now, this is very, I would say, a very subjective slide. But again, we have seen this happening with some of the customers where they migrated from Oracle to Postgre, and they have seen around 95% in terms of savings, right? Again, this is a very, as I said, it's a very subjective slide. It all depends on what kind of licensing you have, right? Now, coming to the Oracle, the PostgreSQL value on Azure, right? As I said, this is a completely community database, fully managed database available on Azure. And when I say community database, it's an extension. It's not a fork like what you see in other cloud. It's an out and out community version, right? What we offer on a community database is that we offer 4 nines of SLA in terms of HA, which means if you go for Azure managed database, even a single database instance of Postgre comes with 4 nines of SLAs, right? Which is a very good value proposition for people running Postgre on-prem, where they have to specially buy an enterprise DB license only to manage an active passive cluster to make sure the high availability is taken care of, right? Because out of the box, PostgreSQL Community Edition does not give you a HA capability. You have to literally build your own enterprise clusters and then look for some enterprise license like Enterprise DB offers to make sure that the HA is managed. But on Azure, this is given to you out of the box. Apart from that, in Azure, we have a unique deployment model where you can convert a single instance PostgreSQL into a MPP architecture where we can vertically shard your data across multiple worker nodes, and you can run your analytical queries in split seconds. Believe me, this is at least about 10 to 20 times faster than a single instance of Postgre. Apart from that, Azure intrinsically offers many values, like it is the most secure and the most compliant public cloud in the world, right? Apart from that, PostgreSQL itself will give you some built-in performance tuning capability. We have leveraged the built-in PostgreSQL extension, which is PG stat statement, to build a intelligence tuning capability on the Azure, right? So out of the box, if you leverage Azure PostgreSQL, you will get recommendation like indexes that can tune your slow running queries. It can find out what are the top weight stats based on which you can tune your database workload. And apart from that, the last and I would say not the least is the way it can interact with other Azure services. For example, Azure Functions or Kubernetes, AKS, or cognitive services or Power BI. These are all built in, which means if you have to build a complete architecture deploying with a PostgreSQL, you are much more beneficial here in Azure because you can integrate it with a lot of PaaS services. Okay, so this is from the value perspective. Now let's go a little deep into the migration strategy. I hope there are no questions till now, but if you guys have any question, keep asking them on the okay, so PO is asking question. PO, I will answer your question later, okay? So from the migration strategy perspective, right, we essentially follow this methodology, right? And you would have, if you would have been to any Microsoft session talking about migration from a database perspective, you would have seen this slide. But this is actually the holy grail of migration for Microsoft, right? Whenever we are migrating, we follow this three major steps, wherein there is a pre-migration done, where essentially what we do is we do the inventory of all your database assets. We identify what application stack you are running on. If there are any in databases which we figure out is hard to migrate because of maybe older version or no supportability or things like that, then we can possibly assess those workload, fix for any recommendations. The assessment might go a level deeper to find out what are the issues and then mitigate those issues or any blockers for the migration. And essentially after that, we look at converting your source schema to the target platform. Now, again, the discovery and the assessment phase is very important because this will define what your target database could be, right? And again, if you remember in the previous slide when I talked about the different pathways out of Oracle, one of the defining factors of which database you could choose is also your application stack, right? So let's say if your application is running with a .NET framework, with typical entity framework kind of ORM, right? It is a natural fit for SQL Server because you would be able to leverage a lot of features that the SQL driver, which we call as the SQL native access snack, right, which provides those kind of things. Essentially, you would be able to leverage that. But let's say if your framework is Hibernate, you're using ORM, Hibernate ORM with Java as your language, that would be a typical fit for a PostgreSQL, right? So that kind of assessment will actually let you know what is the best target platform that you can migrate to. Now, once the pre-migration is done, the assessment is done, we identify what is the schema like and what are the different fixes that you have to do in terms of making sure that the schema is compatible with the target. Then after that we do what is called as the migration of the actual objects and the schemas and the data, right? So we migrate the data out of your Oracle database to the target system. We migrate the schema objects. A lot of validations would be done here to make sure that the data is validated and correct at the source as well as at the target. So people choose to run a simple count row kind of a query, or there have been scenarios where people have run checksum to make sure that the data at both the locations are same. So that is also completely possible. Now, once you migrate the data, depending on what is your application downtime that it can kind of withhold, we will either choose to synchronize the data for a longer term, or we can simply cut over the application once your complete data is loaded to the target, and then cut over the application to do the post migration step. Now, data sync, there are multiple choices here. I will talk about this in the demo, which I will show a little later. So once that is done, in the post migration is where we do a very iterative step, and the iteration is essentially to remediate the application out of any bugs or issues, or even to optimize for that matter, right? Now, once you migrate to, for example, Postgre, there are a lot of features or extensions that can be leveraged to make sure that your what you were doing in Oracle can be done in a much better optimized way, right? So there is phase activity within this post migration step where we look at a lot of different codes, optimize it to use native features rather than using compatible features, right? Because native features will give you much more better performance. Now, this is the whole migration methodology. Okay, from the tool perspective, right? What tool can we use to do a end-to-end migration? We will leverage what is called as Ora2PG. Now, Ora2PG, if you've seen, is an open source tool which is available. It has a very good documentation. The code is available on the GitHub. You can, in fact, download the code. Even give a lot of. If you find any way in which you can contribute to better the code, please do so. And apart from that, you can even kind of interact with the contributors by opening issues or bugs or learn from them, right? So Ora2PG is a common tool which is used for doing end-to-end assessment as well as migration. What Ora2PG will do is it will essentially read your Oracle catalog and create an equivalent PostgreSQL object. So in terms of tables, views, sequences, indexes, all that can be migrated automatically with the help of Ora2PG. Although there are certain consideration which you will have to do, and believe me, the assessment that Ora2PG will do will give you a good view in terms of what are the complexities that you will have to look for when you're trying to migrate from Oracle to Postgre. Other than that, Azure DMS is another data migration option, but right now Azure DMS only supports the migration of table schema and not the programming objects like functions or views and all that, right? So you have to keep this in mind. Ora2PG will also provide you, as I said, assessment report where it will give you a lot of different recommendations, right? And it has a lot of supports for even things like PostGIS, the spatial data type in Oracle, right? You can migrate it to, it can automatically migrate it to PostGIS extension in PostgreSQL also. So what I will do is we will use this Aura2PG to run an assessment on an Oracle database and then see how we can migrate it to the PostgreSQL. That would be for the demo that I would be doing. And in the demo, we'll look at a scenario where we will try to migrate an Oracle database to Postgre in an online fashion. And when I say online, we will leverage the archive log capability of Oracle to stream the changes from Oracle into PostgreSQL and make sure that we can run both the systems parallel until the delta changes are available on Postgre, right? So we will be looking at this particular pathway, as well as we can look at this pathway as well, right? So with Aura2PG, what we will do is we will look at initial assessment, identify the target data source based on the assessment, do a schema code conversion, do the data migration using DMS or using natively, right? DMS I will talk about a little later, but let's say if you have to do a offline kind of a migration, right? So Aura2PG can be used to export the data into a flat file as well, and then use Aura2PG to again import it back to PostgreSQL also, right? Or else you can simply take a CSV dump of your Oracle data and migrate it into Postgre. That is also possible. Or else if the data is not huge, you can use the in-memory export capability of Aura2PG, but I would give you some hints here. This is not a very, I would say, if you have a lot of blob columns in your Oracle database, large object kind of objects, data types in your Oracle database, this can be really slow. So always try to make sure that you're using the right tool for the migration. This is where probably DMS can help you, right? So what is DMS? So DMS is actually a Azure data migration service where you can migrate off your on-prem or other cloud databases seamless to any of the targets, right? So it gives you capability of migrating to heterogeneous environments also. So you can take a Oracle database, migrate it to a SQL or MySQL or Postgre or Postgres hyperscale as well, or it can be any other database, right? You can also migrate SQL Server to a heterogeneous environment or MySQL, right? Now DMS has the unique capability where it can work on internet, it can work on express route, or you can even create a site-to-site VPN between the two, cloud or on-prem versus Azure, and then migrate the data across to Azure databases. So for demo, what I will do is we will use first the Aura2PG to assess the Oracle database and export the schema and import it into PostgreSQL, and then we will try to use DMS to migrate this data from Oracle to PostgreSQL in a online kind of a fashion. So for my DMS demo architecture, what I have done is I have created two VNets in my Azure subscription. One VNet is where my database is hosted, the Oracle database, and another VNet is where I have data migration service hosted. Right now, for site-to-site connectivity, what I have done is I have created a virtual subnet within that database VNet, and in this subnet I am hosting a gateway. And similarly, in the DMS VNet, I have again created another subnet where I've created a gateway, VPN gateway, and connected them using iKey site-to-site VPN tunnel, right? And in my database VNet, I have also installed Aura2PG in the same VM, but ideally this could have been a separate VM also. But just to save cost, I have installed Aura2PG in the same database VM, right? So this is the architecture that I have. Now let's look at how I have implemented this on my Azure subscription. So this is my Azure subscription, and also I will share some URLs that you can go through. For example, this is complete documentation of what Aura 2 PG looks like, how what are the different options, how can you configure in different types and all that. And you can follow this tutorial which I have followed, in fact, to make sure this migration works. Although I have encountered some issue, let's hope that in this session my demo works, right? So we will always keep our fingers crossed. So I will share these URLs with you guys so that you can look at these links and learn from it, right? So coming back to my demo architecture, right? So let me explain this a bit. So as I said, I have a resource group called migration resource group, within which I have created a VNet called migration VNet. The address space there is right from 10.0.0.0 to up to 16, which means I get these many address ranges. Within that, as I said, I have created two subnets. One is the default subnet where my database VMs are hosted. Another is a gateway subnet where I have installed the VPN gateway. Okay, I will talk about the VPN gateway a little later. So this is my migration VNet. Similarly, I have a DMS VNet in a different resource group called NDMS RG. And this VNet again has a different address space, right? This is to make sure that when you connect the VPN, there is no overlap in terms of the IP addresses. So always make sure that you are keeping the address space different from your on-prem or other cloud IP addresses. Otherwise, this might not work. And similarly, in my DMS VNet, I have two gateways. One is the default gateway where my DMS instance is installed. And then I have a gateway subnet where my VPN gateway is installed. Now let's look at the VPN gateways, right? So in my DMS, I have installed this DMS virtual VPN gateway, virtual network gateway. Essentially, this is a simple point site-to-site kind of a VPN that I've configured here. You will look at different configurations that are available. What SKU I have chosen? It's a this SKU is basically the cheapest SKU in the gateways for that matter. As you move ahead, you will get more capabilities, right? But for a demo perspective, I have chosen the basic SKU. From connection perspective, you will see that I have a VNet to VNet connectivity between my migration VNet to my DMS VNet. These two virtual networks are connected. And similarly, in my migration VNet also, I have created this VPN gateway. Now this gateway again does the same thing. It has a connection from my migration VNet to my DMS VNet, right? So till here, are you guys following what I'm doing? So essentially, what I showed you was this VNet that I have created. Okay, sorry, I wanted the laser pointer. So I showed you this VNet which I have created. I showed you the two subnets which are created. I showed you the gateway connectivity between the two, and similarly the DMS as well, right? Now let's look at the database VM. So within my migration resource group, I have couple of VMs here. One of them is a Windows virtual machine, right? And I am connected to this using RDP here. Let me look. Okay, my RDP is gone. Oh, okay. This is because I have an auto shutdown at 8 o'clock. Okay, sorry. Yeah, in demo environments, you have to really save cost. So by the time the VM starts up, are there any questions, anything? So I see some question here by PO. Number one common reason for migrating out of Oracle licensing cost is. So I'm not sure, PO, are you asking me a question or telling me a...
No. I'm just sharing the.
Sure. So I think, I think PO is right in some way. There are more and more application needs where applications are being developed to handle multiple databases and multiple structures for that matter, right? So I've seen application using NoSQL in the same application. I've seen applications using relational store, NoSQL stores, big data stores as well, right? So for that kind of scenarios, definitely cloud gives you much better capabilities there. Are there any questions? I mean, I'm just looking at my VM. It will take some time to start. Meanwhile, if there are any questions, do let me know. Look like my VM has started. I hear some noise. Is there any question? Okay, if none, then let me walk you through the setup here. So this is my VM, which is hosted in the database subnet, and this has Oracle installed in it. So if you see here, I'm using a SQL developer to connect to my Oracle instance. I'm sorry, guys, I did not check the. I should have prevented it from shutting down because I will have to start from zero now. So, okay, so my SQL developer is up, and so I'm trying to migrate off my Oracle, my HR schema here. If you know Oracle, you know HR schema, right? So HR is okay. Essentially, okay, let's see if the Oracle is up or not. I believe it is up, but let's see this. Okay. Okay, so it I think it is up. Describe. Or this should also, because this is a new version, right? So this should also, okay. Okay, so I'm using the container database, right? So this view will tell me, okay, so as of now, I think my database is not up. So let me up the database first. Okay, so let's see if I can connect. Okay, looks like it is opening up. Yeah, so, okay, I think because my VM was shut down, the pluggable databases essentially whenever Oracle starts, they are not open, right? They are in mounted state only. So, okay, anyways, so we have the database here. And I am taking the HR as a sample schema to migrate off. You will see the different tables, the views that are available for us. Then there are procedures. I don't think there are packages installed here, but then there are indexes. and all these things that are available, right? So what we will do is we will now this is my Oracle database, and in the same server I have Ora2 PG also installed, right? So if you remember what I talked about Ora2 PG, basically this is a lightweight installer. Lot of details are given on the installation and all that. There is even a PowerShell script which can do all the steps for you. So if you're looking at installing this, and if you're facing any problem, just ping me and I can help you in that, right? But essentially once you install it, it requires a lot of things. It requires Strawberry Perl executor, it requires Git, it requires the make utility to compile the code and all that, right? So all that can be installed if you have that PowerShell script, and I can share that URL also with you. But once it is installed, you can verify your installation by running this thing, right? And then what you need to do is copy. By default this file will not be available, right? So this is the configuration file based out of which the Ora2 PG works. Now what you can do is you can copy this file, because this is your sample configuration file, and once you have copied that, rename it to ora2pg.conf, right? And make all these changes, right? So primarily what you need for changes is mostly for these four things, right? So you need to provide a Oracle home so that it can leverage the Oracle drivers, the client drivers. Because I'm using the same machine, I can leverage the Oracle drivers which are installed along with the database. But let's say if it was a separate machine, you would need to download the client driver, Oracle client drivers, and provide the Oracle home path here, right, where you have installed the drivers. Then you need to provide the Oracle DSN and the username password that you want to connect it with, right? Now since I'm using TNS names, TNS connectivity, I can simply provide my Oracle service name here, and that's it, right? If let's say you were using Easy Connect or naming other naming conventions, then you would have to provide complete string like data source, like the local host, the port number, and what is the service name, right? Now because I am using, you will see I'm using the TNS naming convention, I've already created a service name for this service, and that's how I'm connecting my Oracle to my Oracle, right? And then I provided username, password. The other things which you need to take care of when you are doing your initial assessment is you need to make sure you mention what schema you want to migrate. Right now, Ora2 PG by default will give you capabilities where you can look for the different schemas that are available in the database. But it always is good to make sure that you pinpoint which is your application schema that you want to migrate, right? And then there are other factors that or other parameters that you can tune. One of the important one that I have seen is where you can define what type of objects you want to assess, right? Whether you want the comments to be available with the table definition or not. And then there is one where you define the one minute. So this is where you define the transaction level of data export. Now this is very important, right? Essentially for demo I'm using read-only transaction capability, but for a production move where you want to make sure that you only take consistent data, you need to at least go for serializable or read committed isolation level, right? This will make sure that you're not doing any dirty reads, because if you don't do this in a production database where you see a lot of workload or transactions happening, anything other than the serializable and read committed can give you strange behavior, right? So these are some of the parameters that you need to be aware of. Now, once you've made these changes in the Oracle configuration file, next thing what we will do is we will test for the connectivity. So we will, Oracle PG gives you this type where you can say show underscore version, and this will actually connect to the Oracle database and show what version it is running, right? So this kind of gives you one confidence that okay, you can connect to the Oracle database. Because believe me, 99% of the time when you're running this, you will face challenge in the Oracle installation, Oracle driver, and the connectivity, right? So please make sure that the some of the points that I listed are followed, right? For example, the naming convention. Also look at the listener, whether the listener is up or not. So those kind of things can definitely help in the initial assessment. Now, once that is done, right, what you can go ahead and do is look for what are the different schemas that are available, right? So there is a switch which shows what are the schemas that are available in your Oracle database. Then you can run something like this: show me all the tables that are there in the Oracle schema, right? Sorry, I think, right. So these are different switches which will go into Oracle database and run some preliminary test, which would mean that it will tell you things like whether you have accessibility to the schema or not, whether you have accessibility to all the tables or not. Those kind of things can be done using these preliminary switches. Now, once that is done, right, the next step is where you actually go ahead and start migrating or doing the assessment of your schema. Now, what I will do is, rather than running the actual thing, I will show you the existing reports that I have. The reason being, my VM is not a very beefy VM, right? So you will see it is already spiking on the CPU, right? So it will be a pretty slow, so I don't want to waste everybody's time. But you see, it will go into each table, find out how many rows it has, right? It will also tell you what are the top 10 tables by rows, what are the top 10 largest table in terms of space and all that, right? Now, this is a very demo kind of a schema, so you will not find very surprising numbers here. But yeah, on your system, this could be very huge. So let's, so the next command is to run this, right? So this essentially will run through your Oracle database and show you a report which will tell you what are the different objects it has identified and what is the capability of Oracle PG to convert them into the target of PostgreSQL database, right? Now this will take a lot of time, so I will not run it, but I have a sample report which I ran some time back. In fact, yesterday, a couple of days back, and you will be able to see what this report looks like once it opens up. I'm not sure why. Okay, yeah. Maybe I need to scale up my server. Okay, but anyways, so if you look at this database, right, this report, it will give you a lot of details. For example, what was the name of the schema that it assessed? What is the size of that database or that schema? What are the different type of objects that it identified in the Oracle database, right from things like DB link to global temporary tables to indexes and different things. It will look at each and every object, find out how many numbers of objects are there and whether they are valid or invalid at the source, and also provide you a comment as to what could be the target structure for that particular object, right? So for example, if it's a DB link that you're using, you can always export it to Oracle as a foreign data wrapper using Oracle_FDW. If it is a global temporary table, by default Postgre does not support it, but you can rewrite some of the application to match the temporary table behavior of PostgreSQL, or you can use things like unlock table in PostgreSQL, right? And it identified 19 indexes. 11 out of them have some concern in terms of the export because they are B-tree indexes with some, I would say, there could be some special consideration which we will have to give. It also looks at how many jobs you have, how many procedures you have, how many sequences, and then gives you the relevant structure in Postgre, and then the other objects, right? What essentially it will come up is, right now I have not run a very detailed analysis, but if you have any invalid or any unsupported type, you will also see another report here, part of the report, which will tell you what are the remediation factors for that, right? Typically you will see things like where a particular view uses some kind of a Oracle functionality like DBMS underscore views to do some special things, right? Those kind of views can be listed here. Those kind of programming constructs can be listed here, and it will also tell you what are the remediation factors that you can choose. Now, once your assessment is done, you've looked at the schema, you feel confident that this can be migrated to Postgre. The next step to do is run these commands, right? Now, by default, Ora2PG will export only one type of object at one time, right? So you will have to override, either you can make changes in the configuration file, or you can mention here what type of object you want to export, and then say, okay, export it as a table.sql, right? So what this will do is Ora2PG will go into the Oracle database, find out all the table structures, and export it as a SQL statement, which is PostgreSQL specific, and it will automatically convert all the structures, all the data types to the relevant PostgreSQL instance, right? So if you look here, I've already taken the dump. Now you will see it automatically converted all the table types, all the data types to PostgreSQL equivalent, right? I did not disable the comments. That's why you will see the comments also are passed on here. Also, all the primary keys and all that are written in Postgre native PGSQL, right? So similarly, you have to run it against all the different type of objects. For example, procedures, right? Views and all that. Now, once this is done, what you need to do is you need to load this into the target PostgreSQL. Now this is where you will go ahead in your Azure portal and create a new PostgreSQL instance. Now I have already done that, but I can show you what it looks like. So in my PostgreSQL resource group, let's say I want to create a Postgre here. I can click on add. I can say PostgreSQL. Select the Azure database for Postgre, click on create. And as I said, there are two deployment models. One is hyperscale, which is the MPP architecture. Then there is a single server. So let's go ahead and create this one. So no PO, it does not have the DMA capability where it can actually run the actual statement and do the analysis. but it can do a lot of things like comparison of schema between Oracle and Postgre, and tell you if you have migrated the schema properly or not. So those kind of comparisons can be done. Okay. No, there are no other questions. So let's go to the creation of the Postgre, right? So here you can specify what version of Postgre you want to create, what is the configuration of the server. For example, how many vCores do you want? So there are multiple SKUs available. You can go to general purpose, memory optimize. You can have multiple vCore CPU. You can scale up and down the storage. Also, you can specify how many days do you want the backup to be retained. It can be from 7 to 35 days, and so on and so forth, and then go ahead and create the database. So now I'm not doing that because I have already created one, and we will be using this database to migrate to. So first thing, when you deploy a PostgreSQL database on Azure, is you need to make sure that your VMs are your VM can connect to this, right? So either you make sure you whitelist the IP in the firewall, or create what is called as the private link, right? So because I was using a basic version does not give you a private endpoint, but if you use a general purpose or memory optimize, here I can create a private endpoint. So essentially, if you go back to this diagram here, right, what I can do is I can spin up a PostgreSQL, create a private link, and from private link I can directly connect to my this database VNet. I can create that private link IP in either in this subnet or this subnet, and then my DB VM can directly connect. So for now I am not doing that, but that is totally possible. So I have a basic version and I have already enabled my connection security. So I go back to my VM, and here I will use a tool called pgadmin, right? If you guys are using PostgreSQL, probably you would have come across this tool. This is again a community tool which is used for management of PostgreSQL databases. The same applies to Azure Postgre also. You can use the same tool for management of Postgre on Azure. So till the time this comes up, let's see if we have any further questions here. Okay, any questions?
I think no.
Okay, so I keep going here, right? So my pgadmin is spinned up, and now let's try to connect to my source target database. So these are my different PostgreSQL, and you will see NPG SQL which I created on Azure, and I can connect to it because I whitelisted the IP of my VM. Now what we want to do is migrate this schema to PostgreSQL, right? What I will do is I will create an empty database here. Now again, this could be depending on how you configure your application. You can create a Oracle database, any other database. Under that you can have a schema called HR, and there you can migrate. But I would like to call this database as HR, right? Just to simplify things. So I create a database called HR. Once this is created, what we will do is we will go ahead and execute these queries to create our sample database, right? Meanwhile, if you see, my export has finished, and it will scan through all the table and do the export, right? So similarly, you will do it for the other objects like triggers, sequence, views, procedures, and whatever you identify in your report, right? So once this is done, I connect to my HR database, And right now you will see in the public schema there is no table that is there, right? So we will open a new query window here and pull out the table script and run it here, right? So you will see this schema which was created by Postgresql Aura to PG. Now it is supposed to be run through client CLI kind of tool like PSQL, right? But for now what I'm doing is I'm just running it through this GUI. So all the PSQL related queries will have to be commented out. So you will see right now no table here. The moment I run this, if it runs successfully, your table would have been created. Okay, so if I refresh this, you will see that the tables have been created. Now similarly, I will run it for the other objects. For example, okay, now this is a catch, right? So if you're running 9.5, PostgreSQL 9.5 does not have the capability of creating procedures, and that is where you will see this error, right? So if I run this, you will see an error saying that create or replace procedure syntax error. That is because Postgre 9.5 does not have the concept of procedures. Now closest match to this would be to convert it as a function, right? And there are some changes here that you would need to do. For example, functions always expect a return type, right? So you can always replace it by return void step and then run this. So what this will do is this will actually create a function. Right now you see there is no function here, right? Only 3 of them. The moment I create this returns void, sorry. So once you create this, right, it would have created this function here, right? So this way you will have to convert your stored procedures into function. But if this would have been Postgre 11, you don't need to do this, okay? Because Postgre 11 supports the different procedures as well. Okay, so this is how you will create various objects. Typically, the stored procedures is something which you have to look for. Again, views pretty simple. They will work as it is. Okay, 1 minute. So views, again, it should run as it is, no issues here. I will just comment this out, and you will see the views should have been created by now. Right, so it was only one view that has been created. Similarly, you can create sequence and other objects as well. So let me comment this out and create the sequences. So right now I believe there are no sequences here. The moment we will create this, you will see the sequences also created here. Right, so this should give you some idea about how do you migrate the Oracle objects to PostgreSQL. So there is just one trigger here. Again, the same thing. We will run that code here and make sure that the trigger is created. There are actually two triggers here, right? So we will go ahead and create them. Okay, so the objects have been created. I have a sample skeleton schema that has all the objects that were exported from Oracle. The next thing is I can either use Oracle Aura to PG to run the in-memory transfer. If you go back to my slide, right, you could run the Aura to PG -t copy. Now copy is where it will dump the data, or else you can use this construct also. So I can say, okay, -t copy and dump it as an file as data.sql in the same directory. Now what this will do is it will go through all the tables, dump that data into my this folder here as a file called data.sql, and that will have all the copy commands which will migrate my data from Oracle into a flat file, and then flat file to PostgreSQL. Now, if we want to do a more online kind of a migration, which is what I will demo in the next few minutes, this is where we will use the DMS. So let's start with the DMS, right? So again, DMS can be created by clicking on create resource and then choosing the DMS. Again, I will not spend that much time there. I will just go ahead and show you what I have already created. Now, once you create a Azure database migration service resource in your subscription, vanilla out of the box, it will not have any projects, right? So once the service is provisioned, you can go ahead and create a new project and specify a project name. So I say Oracle MIG project 1, specify the source, which is Oracle, specify the destination, specify whether I want to use online migration or offline migration, and create and run the activity. Now, by the time my table and all that is being migrated, let's see if we can also do this through the now there is a couple of things, right? Again, as I said, if you are leveraging the standard mode naming convention, easy connect naming convention, you can use standard mode, right? You just provide your source IP, provided the connectivity is there, or else use the connection string mode. Now here you can actually use the same TNS the connect string that you created in TNS, the same can be moved here, right? And just modify the host name. So if I am correct, my host name is okay. So I just move this, specify the username that I want to connect it with, password. You need to make sure that Oracle has 1.2 security protocol enabled. There is complete steps on how do you enable it. By default, when you install, it should be enabled, right? So don't have to worry about that. But let's click on save and see if we can connect to the Oracle. And meanwhile here, if my export is done, it would have exported the data. So yes, so it has exported the data. Let's see if we can see that data, right? So here, if you see, it has actually created the copy commands to dump that data into my Postgre instance. I can simply run this on my Postgre, and it would migrate the data. Right. Again, this is a PL/SQL command, so you cannot run it in the PG admin. But if I do something like that, PSQL, and provide the host name npgsql2 dot so and so, and provide the input file name, it will go ahead and copy this data to my Postgre instance, and your offline migration is complete. But let's try to see this. Okay, so this was expected. I think there is some issue. So one thing which you need to take care of when you provision the DMS is make sure that these ports are opened at the NSG level to the Oracle database that you would connect to. So you see here, I have already opened that, right? So you have to enable the DMS ports that it will connect to, and also enable the database port, and make sure that you're not exposing it to the internet, but only expose the DMS address space. If you remember the VNet address space, right? Take care of that. The other thing which you need to take care of is the firewall in your so within the firewall, I have already enabled my inbound rule where I'm allowing all the ports from DMS as well as which will connect to the DMS and all that, right? So these all things you need to make sure that it is up. You need to make sure that your listener is also up, right? So you can do this listener, okay, sorry. And then you can check the status of your listener, whether it is up or not. So the listener is up, right? And in fact, from a command prompt, I can connect to this HR at over CLPDB and provide HR. Okay, I can connect here also. So all these are some of the remediation steps that you will take forward to make sure that connectivity is not an issue. But I think there is some problem that I've been facing since couple of days. I've already sent a feedback for this. You see, the error is not very prominent, right? It will not tell you what is the issue. But believe me, I mean, it should work for you. I think there is some problem which I have not overseen, which I have overseen, due to which I am not able to connect. But it has all the steps, right? All the steps are listed here. So if you see, once you go ahead and connect to your Oracle database, you connect to your Oracle database, then you it needs a OCI driver to connect to the Oracle. Once it is connected, you specify the target and then specify which schema you want to connect, and that's it. And then it will do the automatic migration. It will also take care of all the incremental data that is coming to your Oracle database and perform the final cutover also. So yeah, I think we are short on time, so I will not spend time in troubleshooting this, but I believe this should have given you some idea about what it looks like. Any questions before we call this off? I think PO has a question, which is procedure function. Was it flagged during, or you will have to manually look out for these issues? No, so this Aura 2 PG will not flag out that your Oracle has a procedure and it will not fit in the Postgre. That is something which you will have to look at manually. Does anybody else has any question? I believe there are some. Okay, there are around 12 participants. If you have not slept, if you have any questions, do ask me.
Actually, it's a very interesting topic.
Yeah.
Sorry, Pio, I could not understand. You said.
No, I was just saying that I wasn't sleeping. It's a very interesting.
Okay, yeah, this is actually number one discussion that we are having with our customers right now, where they are looking to migrate off Oracle, and that's why I thought this would be an interesting session for the community as well. Okay, if there are no questions, I think we can call it off.
I have one question.
Yes.
If there is data like petabyte or terabyte, so how, is there any limitations for migration, kind of migration?
Actually, no. We have used DMS to migrate around 3 terabyte, 6 terabyte, even 8 terabyte of data, right? There we were looking at offline, so we used Azure Data Factory, but DMS inherently does not have any limitation, just that by default the VM that DMS creates, right? The DMS creates a VM, right? This VM will have by default storage of only 2 terabyte, right? So wherever you see that the initial dump of the database, the snapshot of Oracle will be more than that, make sure you raise a support request and ask the support team to increase the size of your VM disk to that much, whatever you are anticipating, right?
Yeah. Okay.
So that is an important thing. And then, I mean, other than that, DMS does not have any limitation. Yeah, there are some limitation. Okay, sorry, I did not mention it. Your Oracle database needs to be in archive log mode. That is some, because it works on the archive log data, right? So it takes changes from there. So it has to be in archive log mode. And there is a cookbook which is available. Just go through this, and this will tell you what are the different gotchas typically that you have to look for in this kind of migration. So this has a lot of high level approach, as well as what are the each step that you have to take, and some of the recommendations also are listed here. Sure. So I believe that should give you some good idea.
Okay, thank you so much, sir.
Sir, I have a question.
Yes, sir.
These DMS service or the Aura to PG, do they handle the mismatch in the data types if there is any?
Yes. So that is a very good question. Actually, when you are creating the schema, right, Aura to PG has a lot of switches. So here you can in fact tell them that particular data type should be replaced by another data type when you are doing the migration. Typically, we have seen, for example, Oracle uses numeric with certain precision, right? If you want to have Postgre with a different precision or different data type altogether, you want to migrate it to big int for that matter, right? You can mention that here, or you can mention it in the configuration file also, and it will handle those data type conversions as well. And a lot of other things are mentioned here. For example, things like encoding, right? For example, things like how many parallel Oracle tables to load, and then it has different switches to influence the different export type and all that as well. So go through this documentation. It has a lot of information.
Yep. Thank you.
Okay. Any other questions? Okay. If not, then thanks PO, Nilesh, Asif for giving me the opportunity to present here. Yes. I hope the session was useful. Do leave us any feedback, and to improve, definitely we are looking for such feedbacks. Thank you.
Sure. Thank you so much, sir. Really nice session and very helpful. Hi guys. I think there is a feedback link I have provided in the chat box. So if you have any feedback, you can just provide the feedback by clicking on the link. And I have just one announcement as well. By next week, we have not next week. It's on 29th September. There is one session for the blockchain.